Morning. Happy Friday. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. Alrighty, so today we're going to eventually get to section 8.4, but I have one question that a student emailed me. We'll start with that, and then if you have any others, we'll look at those. This is from section 8.2, number 9. I think this is from 8.2, part 2. Anyway, it says, write an equation for a linear function whose graph has the given characteristics. It passes through the point 12, 0, and it's perpendicular to the graph of g of x equals 4x plus 5. I was looking at the student's answer earlier, and I think the reason they got it wrong, I think they went with parallel lines. They use the same slope, and when lines are parallel, you use the same slope, but when they're perpendicular, you use negative reciprocals. So the slope of this line right here is 4. So the slope of the line that's perpendicular would be negative 1/4. So that's the slope we're going to use in combination with that point. So now we've got y equals mx plus b. The slope is going to be negative 1/4. So y equals negative 1/4 x plus b. Then we're going to take the ordered pair and we're going to put the 12 in for x and the 0 in for y. So we get 0 equals negative 1/4 times 12 plus b. 0 equals what? Negative 3 plus b. Add 3 to both sides and b equals 3. So now we know the slope is negative 1/4 and the y-intercept is 3. So y equals negative 1/4 x plus 3. But finally, using function notation, f of x equals negative 1/4 x plus 3. And there you have it. Alrighty, are there any questions from anyone here right now before we go on? Okay. So let's take a look at section 8.4. And first of all, I want to talk about some streets. Let's see, if this is 16th Avenue, and this is Nob Hill Boulevard, this piece that I'm filling in there, what would you call that?
Intersection?
Right, the intersection. So this would be the intersection of 16th Avenue and Nob Hill Boulevard. All right, let me ask you this. Is this intersection, is it part of Nob Hill Boulevard?
Yes.
Is it part of 16th Avenue?
Yes.
So the intersection, I know you all thought I was trying to trick you with a trick question. No, I wasn't, sorry. The intersection of those two streets is the part that they have in common. So that piece of street is part of Nob Hill Boulevard. It's also part of 16th Avenue. So that would be the intersection, where they overlap, what they have in common. All right. Now, what if John and Sue got married and John had, let's see, what does John have? He has a red car and a blue truck, and Sue has a green, oops, can't spell, car and a orange bicycle. I think I spelled that wrong. B-I-C-Y. There we go. Okay. If they get married, what do they have? They have a red car, a blue truck, a green car, and an orange bicycle. So if they form a union, all of his stuff and all of her stuff become their stuff. Okay. Now, I want to distinguish between intersection and union. Intersection, that which they have in common. Union, everything they both have lumped together. Okay. Now, one of the symbols that we use for union looks like a U. That's pretty obvious. Intersection is an upside down U. Okay. So the symbol for union looks like a right side up U. For intersection is an upside down U. So with that in mind, let's take a look at some problems. And let's say we have the following information. Let's say that at set A equals 0, 1, 2, 3, 4, 5, and 6. So set A contains the numbers or the elements 0, 1, 2, 3, 4, 5, and 6. Okay. Set B contains 4, 6, 8, and 10. Okay. Set C equals -3, -1, 0, 1, and 2. And set D contains -3, 1, 2, 5, and 8. All right. So we've got 4 different sets, and they've each got certain numbers or elements in them. What would the intersection of A and B include? So in other words, look at set A, look at set B. What do they have in common? What elements? What numbers?
4 and 6.
Okay. So the intersection of A and B would be the set containing the elements, so the numbers 4 and 6. Any questions about that? All right. How about A intersecting with D? What do they have in common?
Number 2.
Okay, yes.
And 5.
And anything else?
5.
I heard that. We've got 2 and 5. There's one other.
I see 1.
There you go. 1, 2, and 5. Okay. How about the intersection of B and C?
None.
None, right. Now, there's 2 different ways that we can say that. We can either use this, which is set builder notation, and put nothing in it. So that's an empty set. Or we can use this symbol, which also means an empty set or the null set. Okay. What you don't want to do is do this. If you put the empty set symbol inside of an empty set, the set's no longer empty. So you don't want to do that. Okay. So either this or this to say there basically is no intersection. They have nothing in common.
So we don't want to create a paradox. Got it.
Exactly. Exactly. All right. Now let's go back here, and I'm going to erase some stuff so I have some room. Well, I was going to. Here we go. Okay. What about C in union with D, or the union of C and D? Cud. Cows chew their cud. All right. So now what do I have?
For this one, you have to add them together, right? Because
Okay. So what would I have?
you'd have 0, 1, no, yeah, 0, 1, 2, 3, 4, 5, 6, and then you're gonna have -3 and negative.
Wait. You listed some there that aren't there. You
Oh
said,
wait, it's for C, and oh, I was looking at A.
I know you were, okay. So give them to me in order.
Okay, so -3, -1, 0, 1, 2, 5, and 8.
Excellent. And we don't have to list -3 twice or 1 twice or 2 twice, okay? So if there's a number in both of them to start with, we don't list them both in the union. We just list each number that's present. Okay with that? All right. Now,
I have a question.
yes,
So even though 0 isn't in D, we still list it because it's in C?
yes. Union means everything in here along with everything in there. We
Okay.
put them together. They form a union. So if either one of them has it, it's in the union.
Okay.
Intersection, they've got to have it in common. Union, everything they've got. All right. Let's go back up here and we're going to introduce the word and the word or. In certain contexts, the word or also means union. And the word and also means intersection. The way that I remember this is that if you look at the word and, right there is kind of the intersection symbol. Just saying, that's a little trick I use. Okay, now it says solve each compound inequality if possible. Graph the solution set if one exists and write it using interval notation. So we're going to do 3 things. We're going to solve a compound inequality. We're going to graph the solution set, and we're going to write the solution set in interval notation. All right. I want to remind you, we looked at earlier on this quarter when we were graphing inequalities. If you multiply or divide both sides of an inequality by a negative number, you change the direction of the sign. So don't forget that, of the inequality sign. Okay, so this first one says x is greater than -2 and x is less than or equal to 5. All right. So what I'm going to do, and you don't have to do it this way, but I highly recommend it. I'm going to graph each of these pieces separately so that it will allow me to see what the graphs look like. All right. X is greater than -2. We would have a parenthesis opening to the right and an arrow going to the right. So that is how you would graph x greater than -2. Now, x less than or equal to 5, you would have a bracket at 5 and an arrow going to the left. Okay. Any questions so far?
So how come you put a bracket?
Because it includes equals. So if it includes the endpoint, then that's a bracket. If it doesn't include it, it's parentheses. Some of you may have learned in a previous class to use filled in circles and open circles. Filled in circles were inclusive, open circles were not inclusive. So a bracket is like a filled in circle, a parenthesis is like an open circle. Does that make sense?
Yeah.
All right. Now, but I want the intersection. So I want what they have in common. Well, let's see. These are in common, aren't they? This goes all the way out to, but stops at -2, and this goes up and includes negative or +5. So the intersection zeros on those. We've got 0, 5, -2. It's open at -2 and closed at 5, and it's a line segment in between. And interval notation would look like this, because it doesn't include -2, but it does include 5. So where do they overlap? Everything after -2 up to and including 5. Any questions about that?
So what method will we use in WebAssign to write this down?
That's a good question. I'm trying to remember. Yeah, I don't remember. I think they have some multiple choice stuff. Oh, another, it may, in other words, are they going to ask you to graph it or use interval notation? Is that what you're asking? I think they
Yes.
ask for all of it, just different times. I think they may ask for different things, kind of stuff. Okay. You want me to check?
That's up to you, honestly.
Yeah, I think you'll find out when you get there. How's that?
Yeah.
But you should know how to do each of these, would be the point I would make. Okay, now let's say we've got this x plus 3, excuse me, I copied it wrong already. X plus, oh, here we go, 2 is less than -1/3 x, and -6x is less than 9x. Okay, now the first problem I did, both inequalities were already solved for the variable. In this case, they aren't, so we've got some preliminary work to do. On the first inequality, x plus 2 less than -1/3 x, let's see, I'm going to add 1/3 x to both sides. So that will give me what, 1 1/3 or 4/3 x plus 2 less than 0. We okay with how I got there? 1x plus 1/3 x is 1 1/3 or 4/3 x. I'm going to subtract 2. Okay, I heard you. 4/3 x less than -2. I'm going to multiply both sides by 3/4. So the 3's and the 4's reduce down to 1's, and 2/4 is 1/2, so -3/2. Okay, so solving that first inequality, I get x is less than -3/2. Okay, the second inequality, let's see, I'm going to subtract 9x from both sides, -15x less than 0. I'm going to divide both sides by -15, but because I divided by a negative number, I'm going to change the direction of the inequality sign. Okay, so now what I've got is that. I haven't solved, I haven't gotten the final answer. I don't have the intersection. I just have each of the equations or the inequalities solved. All right, I'm going to recopy that on the next page and go from there. So I've got x is less than -3/2, and x is greater than, oh, where did I make a mistake?
Dividing the 0. I
Yeah,
believe.
You didn't make it a positive, right?
no.
What was it?
What
Oh,
is,
it's 0.
yeah, there we go. Okay, good.
Imagine if that was undefined. That wouldn't have been fun.
Ah, yes. Well, then we could have packed up and gone home or something. I don't know. Okay, wishful thinking, right? Okay, so now I'm going to take each of these. So this is like, now it's like the first problem we did. It's already in that form where it's x is isolated. I'm going to graph each one of these. X less than -3/2. Let's see, I've got 0, and we'll call that -3/2. So it's going to look like that. It's everything below, but not including -3/2. x greater than 0 would look like that, okay? So, and intersection, what do they have in common?
Nothing.
Or you could say that, okay? So the intersection, nothing in common. All right with that?
Yeah.
Okay, we good to go on?
Yes.
Okay, right. Now we're going to solve what is called a double inequality. And let's see here, we've got 4 less than or equal to x plus 3 less than or equal to 7. What we're going to do, we're going to solve this for the variable in the middle. But there's 3 pieces here. There's this, and there's that. Whatever we do to one piece, we have to do to the other 2 as well. So to solve for x in the middle, I'm going to subtract 3 from the middle, which means I'm also going to subtract 3 from each end. So that gives me 1 less than or equal to x less than or equal to 4. Any questions about that? All right. The graph of that is going to look like this. I'm going to have a bracket on 1 and a bracket on 4 and filled in line segment, and interval notation will look like that. So we've solved it, graphed it, written it in interval notation. Any question there?
So for the 1, is the less than or equal to just serving as an endpoint, or?
Okay. Notice x is in the middle. So technically, the way you would read this is from the viewpoint of x. So you'd say x is greater than or equal to 1 and less than or equal to 4. So rather than saying 1 is less than or equal to x, you'd say x is greater than or equal to 1 and x is less than or equal to 4. Does that make sense?
Yeah, sorry, it just took
No.
my brain a moment to snap.
Not at all. You got questions, I've got answers.
What
Go ahead.
happens if 1 is greater than or equal to x in this equation? What happens then?
So, like that?
Yeah.
Technically, you wouldn't write that because it's a contradiction.
I see.
I mean, let's see. Let me think about this. X is less than. Actually, well, x is less than or equal to 1 and less than or equal to 4. I suppose you could deal with it, but it doesn't generally come up. You don't usually have that kind of a situation. So I can see where you might come up with a solution, but it's let's put that in, let's say let's not go there. How about that? It shouldn't come up in what we're doing. All
I'm
right.
going to hold you to that.
Okay, good. Now, take a look at, actually, I want to talk about Hawaii, okay? Hawaii, and this is, I'm not an artist, maybe a con artist, but Hawaii is made up of several islands and they don't look anything like that or whatever, but so the state of Hawaii consists of several islands. Now, the big island, as it's called, is also called Hawaii, which gets confusing to tourists. But then you've got Maui and you've got Oahu and some others. But my point is, when you're talking about the state of Hawaii, it includes several different islands that have different geographic locations. they're not all in one, they're not all connected. For instance, if you take the state of Montana, okay, Montana is just one big piece of land, right? There's no separate islands out there somewhere kind of thing. It's just one big piece of land. But Hawaii has several different pieces. Now, why does that matter? Okay, let's take a look at this problem. It says x minus 3 is less than -4, or negative x plus 2 is less than 0. It says solve each compound inequality, graph the solution set, and write it using interval notation. So the first thing I'm going to do is I'm going to solve each inequality. And with an equation, it doesn't matter which side you solve for the variable. In an inequality, it's best to solve it with the variable on the left. It just makes it easier to interpret the results. Okay. Let's see. So this first one, I'm going to add 3 to both sides, and I'm going to get x less than -1. Here I'm going to subtract 2. I'm going to get negative x less than -2. The second one, I'm going to divide by -1, which gives me x and 2. But because I divided by a negative number, I'm going to change the direction of the inequality. I'm just going to bring this down here so they're all on the same line. Okay, so that isn't my solution, but that's what I'm going to use moving forward. I solved each one for x on the left side. Okay, any questions there? Now let's graph each individual piece. X less than -1. Let's see here. So I've got 0, -1, and 2. X is less than -1. And then I've got x is greater than 2. That's going to look like this. What does or mean?
Union?
Union. So my solution is all of the first and all of the second. I'm going to take all of Maui and all of Oahu, both those islands, they're in the union called Hawaii. So my graph of the actual solution is going to be this piece as well as that piece. So that's the graph of the solution set. Now, notice that is not a single interval. It's not a single clump of land, so to speak. So to write it in interval notation, it's going to look like, hang on here, it's going to look like this. I'm going to go from -infinity up to, but not including -1, because it doesn't have an equal sign there, in union with, starting after 2, going to +infinity. So that's how I'm going to write this answer using interval notation. Recall that came up the other day back in 8.2 when we were talking about domain, and there was a certain x value we wanted to exclude, and so we did this. Now, if they had asked for the intersection, it would have been no solution. They don't have anything in common. But the union, because the two pieces of the union don't overlap, we have to write them as two separate intervals. Just like Hawaii has more than one piece of land separated, but it's still, the union is still including both, or all the pieces. Okay with that? Well, we'll see. We'll see. Okay, how are we doing time? Let's take a look at this one. 1/2 x less than or equal to 2 and 0.75 x greater than or equal to -6. So to solve the first inequality, well, that's good. I just spit all over my screen. Guess I should put my mask on. To solve the first inequality, we're going to multiply both sides by 2. So I'm going to get x less than or equal to 4. Okay. The second one, I'm going to divide both sides by 0.75. And let's see, if I take -6 divided by 0.75, I get -8. All right. And this is an and situation. So we're talking intersection. So I'm going to graph each separate piece. X is less than or equal to 4. So that's going to look like this with a bracket on 4 and an arrow going to the left. X greater than or equal to -8. That's going to be a bracket on -8 and an arrow going to the right. And means intersection. So what do they have in common? Everything, from -8. Let's see, let's go back. So 0, 4, -8. It's going to be everything from -8 up to and including +4. That's in the intersection. And interval notation would look like that. So what do those two inequalities have in common? Everything between and including -8 up to +4. Keep in mind, this continues. You know, I just because I stopped the arrowhead there, it goes on forever in that direction. This goes on forever in that direction. But this is where they shared in common, what they overlapped. Does that make sense?
So if it would have been an or, it would have been infinity.
Yes. Yes. And let's see here. Let's see if I've got one of those. Okay. Yes, let's look at this one. 2x greater than x plus 3, or x over 8 plus 1 less than 13/8. Okay. To solve the first inequality and to solve it with x on the left, I'm going to subtract x from both sides and I get x greater than 3. Okay. The second inequality, I'm going to multiply both sides by 8. So that's going to give me what? X plus 8 less than 13. Okay. 8 times x over 8 would be x. 8 times 1 is 8, and 13/8 times 8 would be 13. Subtract 8 from both sides, and I get x less than 5. I'm going to bring this down here. So I've got x greater than 3 or x less than 5. Any questions so far? All right. X greater than 3. Let's see what that would look like. 0, 3, 5. We're going to be what? Parentheses there with an arrow going to the right. X less than 5. Parentheses at 5, arrow going to the left. Or means union. If we take all of that along with all of that, if we put it together, what do we get? We get all real numbers, and interval notation would be from -infinity to +infinity. Don't put brackets on negative or positive infinity, because that implies that there's a specific number that's called infinity, and there isn't. It's just the idea of going on and on, kind of like I do. Okay? Does that make sense?
Yeah.
Yes.
All right. Let's see here how we're doing. Take a look at this problem. it says -6 less than f of x less than or equal to 0, where f of x equals 3x minus 9. So basically what we're going to do is we're going to take this and substitute it in the place of f of x. So now our statement becomes that. And this is what's known as a double inequality. Okay. So I want to solve for x in the middle. I'm going to add 9 to all three pieces, giving me 3 less than 3x less than or equal to 9. Then I'm going to divide by 3 all three pieces. 1 less than x less than or equal to 3. The graph of that, let's see, 0, 1, 2, 3. You'd have parentheses at 1, bracket at 3, solid line segment between. Interval notation would look like that. All I can figure as to why they're doing this is to just throw some more function notation in there to get you used to it. Okay. All right. Questions before we go on? Okay. 5 times the quantity x plus 1 less than or equal to 4 times the quantity x plus 3 and x plus 12 less than -3. Okay, so to solve the first inequality, the one on the left, I'm going to start by distributing 5x plus 5 less than or equal to 4x plus 12. Okay, I'm going to subtract 4x from both sides. X plus 5 less than or equal to 12. Subtract 5 from both sides. X less than or equal to 7. Okay. The second inequality, the one on the right, I'm going to subtract 12 from both sides and get x less than -15. And I'll bring this and down here. So this is what we're going to deal with. Let's see. X is less than or equal to 7. So I've got, let's see, 0 and 7, and we'll put -15 over there. So less than or equal to 7, we're going to have a bracket at 7 with the arrow going to the left. Okay. X less than -15. We're going to have a parentheses at -15 with the arrow going to the left. And intersection, what do they have in common?
-15.
Actually,
-15 and infinity.
It would be -15. No, not 15. Negative infinity up to -15, right?
but not including -15, because even though it's included here, it's not included there. So it's going to be, yeah, everything from -infinity up to and not including -15. And then your graph would basically look like the bottom piece of this one here. Okay, that's what they have in common. Everybody seeing that? Over here, the bottom one doesn't have it. But over here, below -15, they both have it. This one has 15, this one doesn't. So it stops right before -15, which is why it's open instead of a bracket that would be closed. All right with that? Let's see here. But this one. This is another Let's see, double inequality, we've got 0 less than or equal to 4 minus x over 3 less than or equal to 2. So we want to solve for x in the middle. Whatever we do to the middle, we have to do to both ends. I'm going to clear the 3 as a fraction, so I'm going to multiply each piece by 3. 3 times 0 is 0. 3 times 4 minus x over 3 is 4 minus x, and 2 times 3 is 6. Okay. Notice in the middle, I didn't distribute the 3. I used it to get rid of that 3 in the denominator. Okay, that was the whole reason for that. Now I'm going to subtract 4 from all 3 pieces. Negative 4 less than or equal to negative x less than or equal to 2. So now what do I need to do?
Divide by -1, right?
Correct. But what happens to the inequality signs when you divide by a negative number?
Everything flips.
Correct. So now I've got that. Now, the problem is when we list a solution, you want to go from smallest to largest. So rather than saying 4 is greater than or equal to x, which is greater than or equal to -2, we're going to turn it around and write it this way. Now, I'm not switching the direction of the sign. I'm just switching the whole viewpoint. For instance, Abel, I don't know how old you are, but I'll bet that I'm older than you, right?
That's a safe assumption.
Okay, so from my viewpoint, I would say I'm older than you. But from your viewpoint, you would say that you are younger than me. Those are both correct statements, but a different viewpoint. So we want to have it from the smallest to the largest, not the other way around. So even though I got here, I wouldn't want to stop there. I'd want to go one step further. Graphing that, let's see here, we've got -2, 0, 4, bracket, filled in, bracket, interval notation would look like that. All righty. Let's see here. Don't confuse and with or. That's a big problem. Students come in and they'll do a problem and it's intersection and they do union, or it's union and they do intersection. So you got to be really careful. Think that through carefully and slowly. All right. Okay, so this is Friday. I will be back at 1:15. If any of you have any questions during my office hour. Otherwise, you've got 8.4 for the weekend. And let me stop the recording.